All right, we're here at 9.7, the last section of chapter 9. We're looking at the law of sines and law of cosines. And before we get to using those laws, let's talk about right here the first core concept, which is the area of a triangle. And so what we can do using the sine function is figure out the area. It says the area of any triangle is given by 1/2 the product of the lengths of two sides times the sine of their included angle. So for triangle ABC shown, there are three ways to calculate the area. And so here's what's important. In order for me to find the area of a particular triangle, what they have to do is they have to give you an angle, but they also need to give you the two included sides. So if I'm taking a look at angle A, they must give you side B and side C, the two sides that are adjacent to angle A, or the included angle. So if they don't give you those two sides, then you can't figure out what angle A is. So right here it says, let's find the area. We have area is equal to 1/2 times BC times sine of A. So therefore, you're going to have to know the included areas, or the included angle with the two sides next to it. So if I want to find, let's say, angle C right here, well, what they have to give you are the two adjacent sides. I need to know side A and side B in order for me to find angle C. And lastly, if I want to find angle B, well, they're going to have to give you right here side C and side A. So you can see how I have highlighted in the diagram all the different sides that are necessary for each and every angle. Maybe they gave you the angle and they're saying, hey, find one of the sides. And so you could definitely find, if we take a look right here at, if they give you angle A, they give you side C, then with the equation, you can find side B as long as they give you the area of the triangle. All right. So there is one other tip to finding the area of a triangle. So let's go right here to the main part of our section, the law of sines. What is the law of sines? Well, first off, it helps us find any side or angle. Now, you can only use this if, right here at the bottom, let me highlight it, if you got two angles and the length of any side is given. And to kind of help you remember, think angle, angle, side, or ASA. Remember, no angle, side, side. So, if in a diagram they give you two angles and the length of any side, you can go ahead and set up the ratio that we have right here. And it doesn't matter how you set it up. Whether you have the sign on the numerator or sign in the denominator in the second one. It all works. So it's all personal preference. But once again, you only need to use 2 out of the 3 ratios. Okay, if they give you angle A and side A, then you could find side C as long as they give you angle C. Or you could find side B as long as they give you angle B, and vice versa. So if I have angle A and side A, I could also find, once again, what I mean is you can find side B as long as they give you angle B. Or you could find angle B if they give you side B. Okay? So this is one trick that you can use to figure out right here the angle or side of a triangle using the law of sines. Okay. Now, there is something called the ambiguous case. And we're not going to get to that right here in geometry. Most likely, you'll see that again later, come in math analysis. So if you hear about the ambiguous case, it does exist out there. And kind of the idea of the ambiguous case is, well, remember, in a triangle, sides must correspond with the angles. So larger the side, larger the angle. Well, what happens if the sides maybe are too long and you won't be able to close the triangle on the third side? There is a trick to it, and that's what that ambiguous case is about. But once again, we're not going to worry about that right now. The next theorem right here is law of cosines. Well, in the law of cosines, it's important to know when we can use that. So right here, it's used when two sides and included angle are known. Think about side, angle, side. Or all three sides are known. Think side, side, side. So if they give you all three sides of a triangle, then you can find the angle using law of cosines. Or if they give you two sides and an included angle, side, angle, side, hey, law of cosines is what you can use. So here's the thing. If I want to find, and if when you think about the equation, let's break it down. If you want to find side A, then they have to give you angle A. Okay? That's kind of the bottom line. Or if you want to find angle A, then they better give you, actually, let me go back. If you want to find side A, then yes, you must know what angle A is. But you also need to know of the included, or the two sides of that included angle. So therefore, I think if I want to find side A, hey, we set it up, use our equation. A squared is equal to B squared plus C squared minus 2 times BC times cosine of A. All right, so the front and the back end, they have the same variable. Think A, angle A. Think of the second equation. Side B, angle B. And then side C, angle C. So you have to know, all right, in order for us to find any of these angles or any of the sides, they better give you the angles opposite of it. And then also the next two that are right next to it, okay? The sides that are adjacent to the angle. You got to know when to use them, okay? That's like half the battle and the trick right here to these questions, okay? So let's go ahead. We'll come back to this law of sines, law of cosines, show you how to use it coming right up. So before we get to there, let's take a look right here at our extra practice. And we're going to take a look at number 1. And it says use a calculator to find the trigonometric ratio and then round your answer to 4 decimal places. This is pretty straightforward. You're going to put into your calculator sine 225. Make sure you have it in degrees. And your answer should be negative 0.7071. Okay, and all you're doing is plugging that into your calculator. Practice cosine 111, you should end up with negative 0.3584. Make sure you have that down. Okay, so if you're not getting that, then you're probably not plugging things into your calculator correctly, or you do not have your calculator in the right mode. But hopefully it's in the right mode after all these sections in chapter 9, having done several of them already. So tangent 96, making sure you get the right answer, practicing it, negative 9.5144. Okay, and there you go, 1, 2, and 3. All right, let's take a look next at number 4. So let's see how we could use this area problem. Okay, so I highlight a few things. Look, they gave me this angle. Angle C is 79, and they gave me the 2 adjacent sides of the included angle. Okay, so pretty easy. Remember, that equation that they give you is pretty much just a generic way of finding all of the different sides depending on what angle you need to solve for. So right here, we'll use our equation. Remember, area, and that's equal to, we have 1/2. The 2 sides, okay, that are adjacent, we got 14 times 9. And then for the last part right here, we're going to go ahead and put sine of the angle, which is 79. Okay, so we go ahead, you've got all that stuff, plug it into your calculator, and then you go ahead and get your answer. Make sure you show what numbers you plugged in and where. And then we go ahead, we'll find our area, and it is right here after you plug things in. It is approximately 61.8. And since they don't give us any unit of measure, we'll go ahead and put units squared. Okay? And there's your area. All right. Let's take a look at number 5. Can I find the area number 5? I sure can, because I've got my angle right there, angle F, and the two sides that they give me are the included or the adjacent sides that make up the included angle, 22 and 19. So we'll go back, we'll plug things in right here. Area is equal to 1/2, and think about, like, it's 1/2 base times height, area of a triangle. So we go ahead, we'll just plug in 22, 19, and then we'll have sine of 24. All right. Try plugging that in, and then hopefully you get your answer right here of 85.0 units squared. All right, and there you go. Problem number 5. All right. Moving on to number 6. Now we are going to get to the heart of this section. Okay, figuring out, all right, using the law of sines and the law of cosines. You've got to think right here. Okay, you look at the diagram and say, what information do they give me? Okay, and we could figure out any missing angle inside. Now, remember, the key right here with why would we use law of sines and law of cosines? Well, we don't have a right triangle. And so with law of sines, law of cosines, we can still find a missing angle or a side. So I look at number 6, and I see 2 angles, and I have one side. Okay? And I take a look at my notes, and I'm like, oh, let me go back to here. Oh, when do I use the law of sines? It says when 2 angles and the length of one side is known. Angle, angle, side, or once again, angle, side, angle. All right, well, I've got 2 out of the 3 sides right here, or angles. I could figure out one of the angles. It's pretty easy, right? Because we have ourselves, interior angles of a triangle happen to be 180 degrees. But, hey, we'll get to that later. So let's go ahead and set things up. Take a look right here. I got angle B, and opposite of that is 22. So remember, it doesn't matter when I set things up whether I have sine on top or bottom. But I'll put sine of 30 on top, and then we'll go ahead and put 22 down below. It's the side opposite of the angle. And this right here is going to be equal to, well, let's figure out what we need. If I want to find over here CB, all right, I'll go ahead and put X over here for C to B. Well, I can find that because I do know the angle opposite of CB, and that's 50. So I'll put sine of 50 over X. All right, and then now we're going to go ahead and solve this out. So we go ahead and cross multiply and then solve for X. So I got X times sine 30 is equal to sine 50 times 22. And actually, most likely, how you would want to put this in your calculator is 22 times sine of 50. And then we get X by itself. We'll divide both sides by sine 30. So now we can go ahead, use your calculator carefully, and you'll figure out that X, which happens to be actually C to B, that right there is going to be equal to 33.7. All right. So next up, we need to find the other side that's missing, which is A to B. And I'll go ahead and mark that as Y. So let's not, I've kind of been stressing, let's not use a rounded number if we don't have to. So if I want to find right here y, let's go ahead. The side that an angle that's not rounded, we'll use what was highlighted in yellow. And I'll go ahead and put sine 30 over 22. And that will be equal to angle C. Okay, and angle C right here, if the two other angles is 80, then angle C has to be 100, right? Because the interior angles of a triangle is 180. So I'll go ahead and put sine of 100 and then go ahead and plug in y right here to represent A to B. If you want to put A to B, you can. That's personal preference. Just, I know sometimes because there's two variables there, you may not feel comfortable with it. So it's easier just to put one single variable down. So we got y is times sine 30. Remember, not sin. That's equal to 22 times sine of 100. So last thing right here, we'll go ahead and divide both sides by sine of 30. And then make sure you guys go ahead and plug that into your calculator correctly. Don't forget, parentheses is your friend, especially if you're not getting the right answer. And right here, you should end up with approximately 43.3. Okay, and that is A to B. All right, so let's see, what do we have? We've got all three sides now, and then we'll go ahead and put the last angle down, just in case you forgot. The angle C is equal to 100. And so we have now solved the triangle. And remember, solving the triangle is finding all angles and all missing sides. Okay? And there you go. Law of sines. Just like that. Let's take a look at the last question, number 8. Now, in this problem, it's always important to evaluate the triangle. Take a look at what sides or what parts do they give you. And in number 8, as you can see, hey, I have 3 sides here. So let's take a look at our notes and determine, well, is there anything that we went over that has us deal with 3 sides? Well, let me take a look at the law of cosines. It tells us 2 sides and an included angle are known. Well, that's not the case right here. Or all 3 sides are known. Well, if I take a look right here, all 3 sides are known, SSS. So what that allows us to do is use the law of cosines. And let's start with our equation. A squared is equal to B squared. And then we have plus C squared. And then we have minus 2BC. So always remember, hey, on one side of the equal sign is going to be 2 of the sides. The other side will have just 1. And then we have the last part right here, times, and this is important, it's times cosine of angle A. So what that will allow us to do is figure out, well, what is angle A actually going to be? Well, let's we'll plug things in. Let me highlight in our triangle. All right, we have angle A, and opposite of angle A is 5. So let's start plugging things in. I could plug in a 5 for A. So we got 5 squared is equal to, opposite of angle B would be side B, which is 7. We got 7 squared plus 3 squared minus 2 times 7 times 3. And then we have right here cosine of A. And now we're going to go ahead and figure out the angle. We need to simplify and start. Let's simplify and start putting things together right here. Okay, so we got 5 squared, that is 25. That's equal to 49 plus 9, and then minus 2 times 7 times 3. 2 times 7 is 14. 14 times 3. We got ourselves 42 cosine of A. Now this next part is where students make a lot of mistakes. And the thing here is this. When you look at 49 plus 9 minus 42, a lot of students will combine all of that together. The problem here is you can't do that because that negative 42 is attached to that cosine of A. It's negative 42 times cosine of A. So you can't split that apart. It becomes problematic. So the only thing that you can combine right here on this side is this 49 and 9. So let me go ahead. I'll simplify that out. Or actually, let's just take care of this right now. Is that 49 plus 9 is 58. So what I'm going to do to both sides now is subtract 58. So hopefully you realize, hey, I combined that 49 and 9 to get 58. And so I'm going to subtract 58 to both sides. And then what I have left is going to be 42. Or negative 42. Okay? So you got 20, 25 minus 48, or 58 for that matter. Let's go back here again. It didn't look right. It's going to be negative 33, sorry. And that's equal to negative 42 cosine of A. All right, so now we work on getting cosine of A by itself. So we'll go ahead and divide both sides by negative 42. And we got 33 over 42 is equal to cosine of A. So we're almost there. The last thing here is this. In order for me to find the angle, I've got to take the inverse cosine. So with your calculator, you go ahead and take the inverse cosine of 33 over 42. And after doing that, you should find that angle A is equal to approximately 38.2 degrees. All right, and don't forget, how did I get that? Don't forget your inverse cosine. That's your friend. All right, so there is angle A. So let's go ahead. We got to do the same thing. We'll repeat the process. We'll find angle B next. And angle B, I'll go ahead and highlight this, and opposite of that is 7. Okay, so with our equation, it's pretty much the same. Like on one side you have the angle, the other side you have the side opposite of the angle, right? If you look at the equation, the first one is a squared on one side, and then we have angle A. On opposite sides of that equation. And then you have the two others parts of the equation all listed on one side as well. So right here, we'll start with b squared. So it's going to be 7 squared is equal to, and then we have the other two angles or sides, which is A and C. So we'll put 5 squared plus 3 squared minus 2, 5 times 3. And then we have ourselves, this time, cosine of B. All right. We'll go ahead. We'll begin simplifying all of this together. So we got 49 equal to 25 plus 9. We got negative 10 times 3, so negative 30 cosine of B. Okay, so once again, make sure that when we simplify things, we take the 25 and 9. Okay, we've got to take those two only, and we don't include the negative 30. So 25 plus 9 is right there 34, so we'll subtract 34 to both sides. 49 minus 34, that right there gets us 15. And then that's equal to negative 30 cosine B. So after this, divide both sides by negative 30. And we got cosine B is equal to negative 1/2. All right, we go ahead now and take the inverse cosine of negative 1/2. And so we'll get angle B and this time it works out to get us an exact number of 120 degrees. Okay. Since I know that angle B is actually like 120 and it's an exact number, I want to go ahead, hey, we could do the same thing for angle C, okay? But because I know I have one exact answer, it does help right here that when I want to find angle C, hey, let's take 180 minus 120 minus 38.2. Since we're not having to deal with so many rounded figures, we tend to be able to get a more accurate answer right here. And for that, we end up with 21.8 degrees. All right, and there you go. We found all of these sides and angles, or they gave us the sides, so we found all the angles here. But remember, you can also use the law of cosines when, well, two sides and an included angle are known. All right, so if they give you two sides and an included angle, you could also use that law of cosines right here as well. So make sure you know the two laws. Think about, hey, when can I use it? When does it fit? Based off the information given. All right, and here we go. We are now done with 9.7.